Hello friends, this question is from the test series number 1 and subject name is control system, topic name is basic control system. It's a 2 marks problem, and in the problem we need to find the transfer function of the signal flow graph, which is C by R. We need to calculate the transfer function. So the signal flow graph, it's a very standard method. We always use a mesh and gain formula to calculate the transfer function. Okay, so the first thing we see in the mesh and gain formula is the forward path. How many forward path you have? So you can see that in this diagram we have total 3 forward paths. One is the straight forward path from input to output, that is my P1 is nothing but this is 1. My P1 is nothing but 1 into 2 into 3 into 4 into 1, which is 24. This is a straight line. This is the first forward path. Second forward path P2 is again you can see that from 1 we have this parallel path of gain 2 and then again 4 1. So second power path is 1 into 2 into 4 into 1, this one, which is equal to 8. And similarly we have another forward path which is third, which you can see here, this 1. From 1 we have this parallel path of gain 3 and then 1. This is my third forward path, which is 1 into 3 into 1 is 3. So we have 3 forward paths from input to output in this diagram, right? Fine. Next thing, after the calculation of the forward path, next thing is calculate the loops of the curve. How many loops we have? So you can see this is L1, L2, L3, and you can see here this 2 along with this 1 and this 1, which forms along with this -1 and then -1, this loop forms the L4. So we have 4 loops in this single flow graph. L1 is nothing but 2 into -1, which is -2. L2 is again 3 into -1, which is -3. L3 is a single node loop of gain -1, and L4 is this 2 into -1 into -1, 2 into -1 into -1, which is 2. So we have 4 loops, 4 distinct loop we have in this signal flow graph. And then there is a concept of non-touching loop. So if I may know that how many loops are non-touching, which are not touching each other, so you can clearly see you can see or you can only find one non-touching pair, that is L1 and L3. L1 and L3 are totally non-touching to each other. They are totally distinct from each other. All other loops are touching to each other. Okay, so non-touching pair are loop is L1, L3. What is the value of L1? -2, L3 -1, so -2 into -1, which is 2. Right? Now calculation of the delta. Now we have calculated all the loops and all this, so let's calculate the value of delta. Okay, now delta is a standard formula. What is delta? 1 minus sum of all loop gain plus sum of 2 non-touching loop gain and minus sum of 3 non-touching loop gain, which is not applicable in this case. We don't have any, so just use the value sum of all loop gain, so which is 2 minus 2 minus 3 and minus 1 plus sum of two non-touching loop gain, which is 2. So my delta turns out to be 7. Okay, my delta is coming as 7. Now we have calculated delta. After the forward path loop gain delta, there is something called delta 1, delta 2, delta 3. Every forward path has a corresponding delta. In this delta, what we saw that the loops which are untouched by the forward path. So if you can see the loop forward path 1 is the straight line or baseline, so it is touching each and every loop. So for forward corresponding to the forward path 1, the delta 1 is simply 1 because every loop is touched. Similarly, my forward path 2 is also touching the each and every loop. Forward path 2 is touching L1 here, and from here it is touching L2 and L3. So forward path 2 is also touching everyone. So for corresponding to the forward path 2, my delta 2 is also 1. But the forward path 3, this outer loop. This is interesting because this forward path 3 is not touching L2 and L3. Okay, although this L1 is touched by this forward path 3, but L2 and L3 is not touched. So corresponding to the forward path 3, we will have a delta 3, 1 minus of, what is the value of L2? L2 is minus 3 and L3 is minus 1. So 1 minus of minus 3 minus 1, which is equal, comes out as 5. Okay, so now we have calculated everything. We have calculated forward path gain, we have calculated the loop gain, we have calculated the delta, we have calculated the delta 1, delta 2, delta 3 corresponding to all the 3 forward paths. Now apply the Meson gain formula. So my C by R is P1 delta 1 plus P2 delta 2 plus P3 delta 3 upon delta, which is 24 plus 8 plus 3 into 5 upon 7, which is equal to 6.71. So transfer function C by R is equal to 6.71 for this case. So this is a very interesting problem of 2 marks. Okay, Meson gain formula is a very signal flow graph is a very important topic of this basic control system, unit number 1 of the controls system. In the control system unit number 1, we have 3 topics like block diagram reduction, BDR, signal flow graph. Okay, and then and the problem based on the basic control systems like open loop, closed loop, and simple transfer functions. Okay, so every year you will expect one problem from this at least. In this, the signal flow graph is the most important topic. Okay, although BDR is also equally important, but every year you will get either one problem from signal flow graph or from the block diagram reduction. Okay, so please consider this topic as a very important. Thank you.